Welcome to myprojectbazaar.com. Our project title is Backward Path Growth for Efficient Mobile Sequential Recommendation. In our project, the problem of mobile sequential recommendation is to suggest a route tracing or a set of pickup points for a taxi driver so that he or she is more likely to get the passenger with less travel cost. Essentially, a key challenge of this problem is its high computational complexity. Recommender systems are commonly defined as applications that e-commerce sites exploit to suggest products and provide consumers with information to facilitate their decision-making process. We propose a new dynamic programming method to solve the mobile sequential recommendation problem. It consists of two separate stages, an offline pre-processing stage and also an online search stage. In offline stage, pre-computes potential candidate sequences from a set of pickup points. A backward incremental sequence generation algorithm is proposed based on the identified iterative property of the cost function. Simultaneously, an incremental tuning policy is adopted in the process of sequence generation to reduce the search space of the potential sequences effectively. The goal of this mobile recommendation system is to maximize the probability of business purposes. Along this line, we provide a potential travel distance (PTD) function for evaluating each candidate sequence. This PTD functions possess a monotone property which can be used to be effectively prune the search space. In addition, a batch pruning algorithm is further applied to generate potential sequence to remove such non-optimal sequences of a given length. Since the pruning effectiveness keeps growing with the increase of sequential length, at the online stage our method can efficiently find the optimal driving route for unloaded taxi in the remaining candidate sequences. Moreover, our method can handle the problem of optimal route search with a maximum cruising distance or a destination constraint. Our technique can therefore be effectively employed to address the problem of mobile sequential recommendations with many pickup points in real-world applications. An unloaded taxi cruising on the road not only leads to waste of fuel and time but also may result in traffic congestion. However, there exist many pickup hotspots in taxi trajectories of those high-yield taxi drivers, which can be effectively leveraged to guide new drivers to pick up passengers in a more economical and energy-efficient way. It's a challenge task because we need to enumerate and compare all possible routes derived from a given set of pickup points, which involves a rather high computational complexity. To solve the MSR problem is nothing but mobile sequential recommendation problem. They proposed a function potential travel distance for evaluating a cost of a driving route. Essentially, the PTD value of a suggested route is the expectation of the cruising distance for an empty cab before it successfully gets new passengers when it travels along the route. To reduce the computational cost, two effective potential sequence pruning algorithms LCP and SkyRoute, which are based on the monotone property of PTD functions that have been proposed, so that only applied to the driving route recommendations with the limited length constraint and a small number of pickup points. It's our data flow diagram. In this, we have to choose or we have to identify what are all the pickup points that are available to reach the source and also what are all the pickup points that is available to reach source from destination. In cab inquiry, we are going to inquire how many traces routes which are optimal or which has less amount of time to travel through. Location to travel is nothing but the source and destination which are given by the user. The cab inquiry or the cab center must have to be identify what are all the locations or what are the paths that are specified within the source and destinations. If the taxi driver is online, it performs some route line online search algorithm and then fetch optimum driving route. Then it has to be performed or compute PTD sum function for cost computation. Depending on the cost, it reach the pickup point or reach the destinations. If the taxi driver is not an online, he is offline, the backward path growth algorithm is going to be performed and probability driving routes can be calculated. batch pruning algorithm is used to prune or is used to reduce the unwanted paths that are going to be exceed amount of time rather than the optimum route. Then reduce the probabilities. Then again we are going to perform the PDD subjunction for cost calculation. By comparing the cost of each and every path to reach the destination, it depends on the optimum cost or which path has a less amount of cost that going to be chosen as a optimum path and going there or reduce the pickup point, and finally we are going to reach the destination. Let us see the demo of our project. Start from homepage.java and run file. It's our home page. Proceed to the next frame. Import locations. Then choose any city centers. These are the cities that are present under the city centers AK. Then select any one of them. These are the pickup points to reach the artagwell.ccd. So we are going to identify what are the potential sequences, what are the paths from cap center to reach the source. Then we are going to prune the sequences. Destination nodes are uploaded and we are going to calculate what are the possible sequences. These are the maximum length for each and every sequences, and we are going to prune the sequences. These are the distance and probability vectors for each and every path, and cost calculation for each and every path. Then we are going to identify which is the optimized path to reach the source. Its optimized path to reach the source, it's a minimum length to reach the source, and we are going to identify what is the destination point. These are the cities which are under the city center CA, and these are the pickup points or act as a intermediate cities to reach the destinations, and we are going to identify what are the paths that are going to travel along. Then we are going to prune the sequences. Then we are going to gather the requirements. After the requirements are gathered, cost going to be calculated. Then we are going to view each and every vector and each and every cost calculated that we are performed previously. These are the vector calculations. These are the cost calculations for each and every path to reach the source and destinations. And it's a final path to reach the source, and from source to destination the maximum length could be 65. These are the values that are used to identify the path to be optimized. Thank you.